myself, Dr. Sandeep Gautam. I am Assistant Professor, Department of Biosciences, IMS Ghaziabad, University Course Campus. So today I am going to talk about nanobiotechnology. So talking about nanotechnology, it is an art and science where we manipulate or rearrange the individual atoms or molecules at nanoscale. Anything which is of the order of nanoscale, I think if we bring anything to the order of 10 to the power minus 9 meters, that would be termed as nanomaterial. So basically we call any material as nanomaterial if it's in the range of 1 to 100 nanometers. So nanobiotechnology, the use of nanoparticles in terms of biology is called nanobiotechnology, where we are using nanotechnology and biology as amalgam. So in nanobiotechnology, the concept that are enhanced through nanobiology includes that construction of nanodevices or nanoparticles. This technical approach to biology allows scientists to create systems that can be used for biological research. So basically nanobiotechnology is like something where we are creating nanoparticles through nanotechnology and we are using in terms of biological research. So one of the important aspects of nanobiotechnology is in the use of nanomedicines, where we use this medicine using a particular target drug delivery system. So designing a drug delivery system using nanotechnology, it's kind of a method of delivering medication to a patient in a manner that increases the concentration of the medicine in some parts of the body related to other. So basically what's the importance of targeting drug delivery is, we can have a prolonged exposure to drug, we can localize it to a specific target, we can have a protected drug interaction with a disease tissue. So these are some goals and benefits which can be achieved using target drug delivery system using nanomedicines. If we compare the traditional or targeted drug delivery system, there's a lot of difference why we are switching over to targeting drug delivery system, because if we go for the traditional system, in traditional drugs delivery system we use oral injection or using IM or IV injection. So this medication is distributed through the body through the systematic blood circulation. So what happens when we give the medicine using traditional system, the most of the therapeutic drugs that reaches the organ is not utilized completely. So we have to deliver a high doses and only a particular amount of drug is available to the targeted organ or to the specific organ which is of ailment, where we face the problems like we have some side effects of the drugs, or we have to use a high concentration of the drug. And if we use the targeted drug delivery system, what we do in the targeted drug delivery system, we concentrate the medication in a tissue of interest. Like we just create a nanoparticle which can be of like carbon nanotubes or some gold nanoparticles, whatever we are using the targeted delivery system as a delivery host. So what we do, we create a targeted delivery system where we concentrate the drug of interest attached to it, and it is targeted specifically to the targeted organ or targeted cell. So this targeted delivery is believed to improve efficacy while reduces the side effects, which is normally seen in traditional system where we see the side effects of the drug. So using targeted delivery and nanotechnology, we have to deliver. We have using vehicles. We have to design nanoparticles which works as a vehicle to carry a drug. So this vehicle carry the drug to a specific tissue and facilitate its release. So here comes the nanotechnology where we are using these created nanoparticles or nanosynthesis materials as a carrier vehicle which easily take the drug and can be introduced to the body. So one such vehicle where we are using drug delivery using carbon nanotubes. So though there are many vehicles available, the carbon nanotubes are a good source or a good drug carrier for the drug delivery system. Basically, carbon nanotubes are allotropes of carbon with a cylindrical nanostructure providing a very large surface area. See, you can see through the schematic representation where we are using CNTs and carbon nanotubes as a drug delivery system. So CNT carbon nanotubes is used effectively as a vehicle to deliver drug to a targeted 6 cells such as cancer cell. Let's assume there is a cancer cell and we have to target a specific drug to that particular cancer cell, affecting rather giving the drug to the whole system. So what we do, we deliver this drug using drug delivery system using carbon nanotube. What we do in the carbon nanotubes, the CNTs are used. The cavity of the CNT is used to target the drug of interest, and this CNT is then targeted using tumor targeted ligands. These ligands are very specific to the receptors which are only found on the injured tissue or cancer tissue. So CNT in cancer therapy. If we talk about cancers are rapidly dividing cancer cells, and when we see the cancer cells, they have a high number of receptors for folate and IgG. IgG is immunoglobulin G. So that's the basic difference between a normal cell and a cancer cell. The cancer cell have more folate and IgG receptors. So what we do, we take carbon and nanotubes as a carrier. In the vicinity of the CNT, we fill it with a drug of interest, and this nanostructure is coated with folate, as folate receptors are available on cancer cells. So what will happen when these nanostructures are coated with the folate? They are easily compatible with the cancer cell because they have specific receptors. So these nanostructures bind to these receptors which are available in the cancer cells. So we can use antibodies or with the nanopart structures. We can coat the nanobodies with the antibodies to bind the protein which are. So basically what we are doing, we are taking a nanostructure CNT. In this vicinity of that nanostructure, we are using drug which has to be delivered for the particular targeted cell or organ, and that nanostructure is made compatible to that particular cell or organ. So when the nanotubes are targeted, they are stuck to the cancer cell because, as previously I said, they have the specific receptors. So these nanotubes, the specific receptors bind to the targeted cell, and when they reach, now they have two type of pathways where it can use the nanoparticles with a drug. Either they carry anti-drugs or they can activate with the infrared. So what happens when these nano CNTs having drug, they reach to the specific cancerous cell or the targeted cell. There they release the specific drug attached to it, and if not attached with the drugs, so what happens? These nano tubes CNTs, when we are giving infrared light, what happens? These nanotubes get heat up and they destroy the attached cancerous cell. So in this process, either we are delivering the drug or we are delivering the nanotubes to the specific cancerous cell, and that particular cancerous cell is destroyed either by the release of drug or by the increase of temperature, which ultimately destroys the cancerous cell. So what are the advantages of carbon nanotubes? Carbon nanotubes have a high drug loading capacity and good penetration quality. So what happens using the high drug capacity? So what happens? These nano drugs can be effectively delivered to a particular cell or particular organ of interest, which cause the ailment or which is causing a cancerous property in a cell. So particular amount of a drug can be given to a particular cancerous cell. As these nanotubes have a good penetration, so they can easily pass through the cancer cells and get into it and deliver their drug. These nanotubes function with a larger inner volume. So as the CNTs have a larger volume, as we already know, using when we bring any string to a nano scale, the surface area, the volume increases. So using these CNTs, we have a higher inner volume where can be used as a drug container. So a good amount of drug can be targeted through using these CNTs.